So we will now move on with the questions. We already have a few for you. So the first one, could you emphasize that fully natural ventilation is not allowed in residential buildings? Is the requirement not on airflow indoor air quality criteria rather than the type of ventilation system?
Yes, the fully natural ventilation is not allowed in dwellings. Only mechanical or hybrid ventilations are allowed by regulation, and this is because it was observed that 100% fully natural ventilation pose many problems, mainly lack of efficiency in ventilation, odors, etc. Produced in some cases by thermal inversion, which prevented natural ventilation from performed adequately. So that's why it was decided to regulate this and just allow hybrid or mechanical ventilation. And the second question is the requirement not on airflows.
Yes,
the requirement is related to is closely related to performance. So it's close. In this case, is CO2 has been used as the indicator of the IAQ situation. So what the system has got to achieve is this performance. Is a maximum CO2 concentration in two ways: the average CO2 concentration during the year and maximum accumulated above a value over the year as well.
Then how common is night ventilation for cooling reasons in summer, and is it included in sizing the systems?
No, it's not included. Well, it's not included by default. I mean, it's not included as a deemed to satisfy solution, but it could be taken into account when doing simulations, because the regulations allow to fulfill or to justify the verification of the performance regulation, the performance requirements, via simulation or via the utilization of deemed to satisfy solutions. So this is the beauty of having performance-based regulation. Any system could be tested against the performance-based requirements. So any system, efficient systems, could justify its compliance with the regulations.
Okay, the next question is, how are the flows in new buildings calculated?
In new dwellings, the flows are calculated taking into account what I've just said. I mean, these flows have got to comply with the performance-based requirements. So it can be done by simulation or by just taking the deemed to satisfy solutions, which are continuous flows that have been established for dwellings depending on the number of bedrooms of the dwelling.
Okay, someone is asking if there will be an impact of the EPBD transposition in Spanish regulation.
Well, yes, of course, there'll be an impact, particularly in relation to regulations dedicated to thermal efficiency. I know that these regulations have been updated continuously in order to be in accordance to EPDB and nowadays, for example, I know that the tool that is being mostly used in Spain for energy efficiency evaluation is being updated to include aspects related to the ventilation systems.
Okay, and what are some examples of innovative ventilation systems you mentioned?
Well, it could be anything, but well, one that we all have in mind, and so is the demand control ventilation systems. For example, they are highly efficient and they can allow as well very high levels of indoor air quality.
And is there an approved simulation software?
No. There's not an approved simulation software. This is left open to the designers, and the politics now in Spain are against having approved simulation software in general. So there's not an approved simulation software in the case of ventilation.
I said it was the last question, but more are coming. If I understood well, you said that humidity demand control ventilation system got the technical approval. Is it humidity demand control ventilation based on sensors, or fully mechanical humidity based on the material sensitive to humidity, like in France? Or maybe both?
Both systems are similar to the ones in France, the material sensitive to humidity.
So both are have got the
yeah.
technical
Yeah.
approval. Okay.
Yes.
Does that not mean that a fully natural ventilation system with FX, I don't know what it means, sensor?
Formal lay, maybe?
Maybe, yeah.
Yeah.
Could fulfill the performance-based indoor air quality requirements and therefore can fulfill legislation if verified through simulations. So I don't really understand that fully natural ventilation systems cannot be used to fulfill requirements.
Well, there is a third way of fulfilling requirements, which is, I haven't mentioned it, but now that this question has come out, I mention it now. There is a third way of complying with requirements, and is what we call alternative solutions. This alternative solution, this could be understood as an alternative solution, and of course, it will have to go through the simulation process to demonstrate that using this system, this one or any other in the market, that fulfill the performance regulations that have been established. So yes.
Okay. Maybe one more, Maria? Yes. Is there a link to EPVD calculation when using a demand-controlled ventilation system? For example, through simulation, we can prove a lower energy consumption. Can this be used in the EPVD calculation?
Well, at the moment, the technical approval document of these two systems I have mentioned before contain a section in which it's been provided the necessary data to be included in the EPVD calculation. So this energy saving is taken into account. Okay. Because has been done like this, because the EPVD calculation nowadays lacks from this from the means to do this. Is as I mentioned before, the PVD, the tool that is being mostly used in Spain to do these calculations is been going through amendments to and updates to include this, but at the moment is not available.
Okay, thank you very much, Pilar. I think now I can say that we're done with the question, at least so far. I would like to go back to the first speakers, so Aldo and Luca for Italy, because more questions arrived for you. So the first one is, what percentage of new buildings have a mechanical ventilation system?
There are no reliable numbers on this matter. Let's say, we can say that new buildings, new houses usually are equipped with the mechanical ventilation system. This is a trend, but we have also to say that in many cases you find on the market new houses sold in a way that the manufacturer or the builder say the house is accommodated or is designed to accommodate AIVC, meaning that at the end of the story, if you want, you can install by yourself. The price does not include. And this is a problem, but this is the market.
I see. Then second question.
I can add something.
Yes, sure.
I fully agree with Aldo. The problem, in my opinion, is that there is still a lack of awareness of indoor air quality among the end user. These systems are often installed to achieve a nearly zero energy building targets rated to improve indoor quality, which is certainly important, but still tends to be considered a secondary objective. This is evident from a recent introduction of incentive mechanism that found mechanical ventilation only when, if necessary, after insulation of building envelope in order to prevent mold problems, and not for indoor environmental quality or indoor air quality. So I think there is a lack of awareness in indoor air quality in Italy. And in new construction, there are in non-residential building always is installed, but for work law and for achieve indoor air quality for the workers, but for other is only for energy aspect or mold in some cases.
Thank you. And what is the key parameter when assessing ventilation in Italian building? I mean, from my perspective, the key parameter in France is humidity, and for Spain is CO2. What will be the one for Italy?
I think will be CO2 because it's easily to, it's not a contaminant, it's a parameter. So I think will be on CO2, but humidity still another good KPI indicator. So normally in our standard, you can choose and highlight in my presentation, you can choose the control, and the control normally is on presence of people or humidity or CO2. So it's open.
Okay. Well, it depends.
Basically, humidity is a problem, and CO2 is the parameter to measure the quality of air. No.
So sometimes, if personal speaking in my house, I control humidity, but only because is not linked on human activity, but humidity from the ground and so on, and in other ends. But I control also CO2 just to have an indicator when people are inside.
Humidity can also be generated by the cooking or bathroom or
cooking, or if you have a house on ground level, you are going humidity through the wall, external wall, so increase the inside the humidity, or if you're washing clothes and so on.
Yes. Okay, thank you. We had one more question for Valérie as well. How much is the overall indoor under pressure created by a typical exhaust ventilation mechanical system? For example, in a single family house. And could you explain how this is maintained and divided among the various air inlets? I think you mentioned each air inlet allows 30 cubic meters per hour at 20 Pascal.
Yeah, so the system is designed so that you got maximum 20 Pascal pressure difference between indoor and outdoor when the flow rate in the kitchen is at the maximum flow rate. So it's designed for that, given the airtightness of the building, etc., and the number of air inlet you put. It's designed for maximum 20 Pascal. In practice, we use only the large flow rate when we are cooking, so we are usually at the decreased flow rate. So the pressure difference will be between 5 and 10 Pascal. And indeed, that's a good question. The repartition of pressure just depends on the layout of the building. So you will have less under pressure if you are very far away with a lot of pressure drops with doors, etc., than if you are close by the kitchen. So we do not ensure a certain flow rate per room, a certain supply flow rate. We ensure that at the dwelling level, everything that is extracted is actually supplied, of course, because, well, we would not implode the dwelling, but we don't actually know how much is coming from every room.
We also had questions for all speakers. So the two first one are linked. Do you think natural ventilation will be banned in residential spaces in the near future, if it isn't already? And the second question is for non-residential buildings, same question. Do you think natural ventilation will be banned in the near future? So maybe we can start with Italy on this, and then France, and then Spain.
I would say for the residential spaces, let me say that unfortunately, I'm afraid that it will not bend. And that, no, the point is that we are facing a strange situation. I mean, we are, let's say, pushed in order to improve the efficiency of our houses, meaning that we say we create or we spend money to create a kind of coat around the envelope to change the existing windows with the better, let's say, insulated ones, with the lower transmittance values. And then there is this idea to open the windows to exchange air. Somebody calls it airing instead of ventilation, no? And it seems a kind of, let's say, misleading concept, no? On some respect, you try to close as much as possible the envelope of the house, and then you accept to open it. Nevertheless, there is a strong push from, let's say, other sectors, windows manufacturers, for example. And so I'm pretty sure that this kind of ventilation will not be banned.
And same for non-residential, or do you want to say a specific word on this?
For ventilation, for non-residential, I think it's a different situation. Above all, because for non-residential buildings, typically we are talking of places where there is somebody who is in charge of the responsibility of the healthiness of workers. And for him is a problem if somebody will get sick and can prove that his let's say disease comes from a bad quality of air. And so on this respect, I think that it's my idea that in non-residential spaces, the control of ventilation will be more and more, let's say, accurate, driving to mechanical systems.
Okay, thank you. Valérie, do you want to say a word on this for France?
Yeah, I wouldn't say banned, but it's kind of impossible to meet energy performance and indoor air quality requirement with fully natural system. I myself strongly believe in hybrid system. I think we've got in France at least the climate for that, but fully natural system, in my view, would be almost more expensive to design those system energy efficient and maintaining good indoor air quality than mechanical ones. So I wouldn't say banned, but I say almost impossible to meet standards with fully natural system.
Okay, I think we already discussed it a bit for Spain, but Pilar, do you want to add a word? We cannot hear you. I don't know if there is a microphone problem.
You need to unmute yourself, Pilar.
Okay, sorry about that. In both cases, I don't think can be banned, and it's not currently banned, and it can be banned, but you have to demonstrate compliance with performance regulations. Performance is the key not the ventilation system. So
Yes.
Yeah.
Okay, we'll move on with the next question. How do you see in the near future the impact of the building automation control system on ventilation in both residential and non-residential? These building automation control systems being more and more present in regulation.
Well, it's almost even becoming mandatory in non-residential building with the PBD, so we will have more and more of them. The question is, will the back system will take the control over the ventilation system, or will it just be recording the data that the ventilation system is actually controlling? That's something we don't know, but I mean, back system will help demand control ventilation in a way or another, at least by recording the performance to help assess those performance afterward. So yeah, I think it will help to assess the performance of ventilation system and improve the inspection protocol for ventilation system.
Thank you. The PPD and a couple of presentations mentioned the word health in the context that our ventilation recommendations should account for occupant health. My question is, how do you think this health dimension can be inserted in such regulations? Perception, surveys, health metrics?
My personal point of view is that it has to be, let's say, measured in some way, and measured not to let's say in terms of healthiness of people, but in terms of maximum concentration of harmful substances that are allowed. It's the only way, because then the comfort of health of people can change from person to person. But there are data from the World Health Organization, for example, that sets the maximum acceptable levels of pollutants in a confined space, and it should be done in this way, to me, setting those values not to be exceeded.
Yeah, ASHRAE 62.2 has already introduced the DALI approach to estimate the full health, well, nocivity of the air, the health impact of the air. We are trying to do the same in the next revision of EN 16798-1 or -2. And yes, we need in some way to design a ventilation system to make sure that in general it has an acceptable impact on health. We need to design it from the beginning, so with simulation, and we need to check it on site afterward by measuring the key metrics for health, which are obviously PM, formaldehyde, maybe NO2, radon, and maybe ozone in some cases, but yeah, PM stands for most of it. So we need to think much more about that, because right now we tend to assume, at least in France, that outdoor air is clean and that we bring clean outdoor air in the building, and that's forgetting about the health dimension and the PM impact on health.
And I just want to add that is essential to establish a link between these dailies that Valérie has just mentioned, a link to the performance based on budget of pollutants. I mean, taking into account that different pollutants can affect differently to health. So at the end, what we're thinking of, what we should design is a budget of pollutants.
Okay, thank you. I think we can take a few extra minutes to answer the two last questions. So is humidity control starting to be linked to indoor air quality and health issues? How are regulations moving in this direction?
Oh, that's a tricky one. Someone wants this one? Well, so I think in LCCU, we've got the problem of the pollutant that we discussed also, and we've got the problem also of the moisture and mold growth, which is one reason to control humidity. So I'm not sure what was the question actually, if it was, are we sure that if we control the humidity in buildings, then we will also control LCCU? Or is there a link between humidity and else? So yeah, I'm not quite sure about what was the question here.
Okay, and the last one, is there a comprehensive comparison of natural ventilation, mechanical exhaust ventilation, and mechanical ventilation with heat recovery that includes both LCA and or the special volumes these systems occupy in buildings?
Do you know what a LCA is?
Life cycle assessment, I guess.
Okay, of course.
Sorry, what is it? LAC? LCA?
Life cycle assessment.
Carbon footprint, basically.
Ah, yeah. Okay. Well,
Not that I am aware of. Do you know any study doing this comparison in Italy or in Spain?
No, as far as I know, there aren't.
I'm not sure. I'm not sure. I know there are lots of different studies, but at the moment, from the top of my head, I couldn't just remember any.
And in Italy, on the decree on minimum criteria for environment in public building, in the new revision, we introduced LCA analysis, but only for the building, not for the mechanical system present inside. So I don't have any data on these topics.